So in the previous lesson, we saw that we need to detect hosts that are alive as well as the services that are running on those hosts. In this lesson, we're going to look at methods for detecting if a host is alive. There's three common methods used: ICMP scanning, ARP scanning, and passive listening using sniffing. Let's take a look at ICMP scanning. So ICMP, Internet Control Message Protocol. This was defined in an RFC in 1981, long time ago. Still in use, very common, easy to use application. So most operating systems will have a ping command. Whenever you type in ping and give it an IP address or a fully qualified domain name for a host, it's going to try to talk to that system. It's going to send what is called an ICMP echo request, and that is type 8 code 0, and it's going to expect a response. That response, type 0 code 0, is an ICMP echo reply. And these are actual IP packets. It's IP protocol 1, and if you are sniffing this traffic, you will see that type 8 code 0 going out and the type 0 code 0 coming back to you. So echo request and echo reply. This is an active method of determining if a system is up and online. If it responds to your echo request, meaning you receive an echo reply, you are able to talk to it. Now, more often than not, you're not going to get a reply because of a host-based firewall or a network firewall that's in the path. However, if you are on the same LAN segment, that system does not have a firewall running that is blocking ICMP, then you should expect to see an echo reply. And that tells you that the host is alive, it is running. Now, ICMP is a very common troubleshooting tool. So once you get past that network border firewall, it's, at least on enterprise networks, they're going to allow echo request and echo reply to systems because it allows their help desk and systems operators to determine if those hosts are up and running when an outage is reported. So if you can get past that first layer of defense, that network firewall, particularly in enterprise environments, there's a good chance ICMP is going to work for you. Now here on the screen, we see the execution of an ICMP echo request and the received replies. So this is on a Linux system, and we can see the ping command is executed here with a -C3 switch. That tells it I want to run 3, it's count. I want to send 3 ICMP echo requests and expect replies. We can also see the sequence number of the ICMP message that got sent, the time to live on it, as well as how long it took to receive the response. So 17 milliseconds after the echo request was sent, the reply was received. And then we have summary statistics at the end of the command. Again, this is output from an Ubuntu Linux system, so you might see different output. Commonly on Linux systems, you're going to see the same output. You might see something different on Mac, and of course, you're going to see something different on Windows as well. ICMP scanning ping sweep. So you can ping a single system, but what if you want to determine what hosts are online on this entire network subnet? So if you have a /24 subnet, there's 254 possible hosts on that subnet. What if there was a tool that would allow you to send out 254 pings and then gather the responses and tell you what hosts are online? That's what ping sweep is all about. There are several tools out there that will do a ping sweep. Here in this pictorial example of a ping sweep, we have a host on the left, host A, that is sending out echo requests, and it's going to send an echo request or several to every available IP on the subnet and look for responses and gather those and display the output. Nmap is commonly used for this task. Here we see an output of the Nmap tool using the SP switch, that is for ping, scan type ping. There's also ST for TCP, SU, etc. As well, followed by the subnet we want to scan. So this is a /28, so we have 14 available hosts on that subnet. Once we hit enter on this command, it's going to send an ICMP echo request to every host in this subnet. That's 14 possible hosts. It will display the hosts that do respond. So host is up, 10101, host is up. Given that that's the first IP in the subnet, there's a good chance that is the router for the subnet. We see 9, 10, 15 all up as well. Scanned 16 addresses, 5 hosts were up, and it was done in 1.34 seconds. So it is particularly quick. to use Nmap for ping scanning. Another tool in the Nmap arsenal of features and functionality is an ARP scan. So in order for a system to talk on a network, it needs to know a destination IP address, of course, right? And it needs to know a destination MAC address. MAC addresses at layer 2 are how systems talk to each other. If you need to get outside of your subnet, then you need to talk to a router. So we send out an ARP request and we say, hey, who has the MAC address for, in this case, this network's case, 10.1.0.1. And then 10.1.0.1, it is their job to respond and say, I have it, here's my MAC address. If you want to talk to 10.1.0.1, talk to this MAC address. And then at layer 2, it gets switched based on MAC address. ARP is another way to determine live systems. If ICMP is blocked, there's a good chance that ARP is available. Nmap provides an ARP scanning feature as well. Here we're running Nmap with the SN option. The N right here tells it to not resolve numbers to names. So we are scanning that same /28 network, and we can see hosts that responded to an ARP request. Now you'll notice, if we take a look at the previous slide, we have 5 hosts are up and online responding to ICMP. Now we look at the ARP scan results, we have 6 hosts that are up. We have an extra host in this example that is responding to an ARP request, but not ICMP. So now we know there's another host on this network. Which one is it and why is it blocking ICMP? A couple more tools for scanning ICMP, Angry IP Scanner and WhatsUp Gold. These are both Windows applications that you can just run and provide it with a subnet, and it will go out and scan those subnets for you. WhatsUp Gold will do it in a recurring fashion, so it will, based on frequency, scan everything and then display the results. WhatsUp Gold is more for network monitoring, to know that my web server is up and online, and if it goes down, doesn't respond to ICMP, send an alert to the administrator. Now, we mentioned on the first slide that passive sniffing is another method for determining hosts that are live. I don't have a slide for it, so I'm just going to talk about it here. We can actively try to talk to those hosts and check for ICMP and ARP. Another method is to just listen to the network. If it's a wired network, there's a good chance you're not going to get a lot of information because most of the time you're plugged into a switched network. However, wireless networks, there is no switch in the air. You can just simply, if you are able to put your wireless interface into promiscuous mode, you can just listen to those wireless frames as they're floating around. And that can give you information about hosts that are online. If they're not responding to ICMP echo request, and for whatever reason you don't get an ARP response from them, however they are still online and talking, you'll be able to see that information. Again, there's a distinction you have to make between a wired network and a wireless network. Most of the time on a wired network, you're not going to see those frames unless you inject yourself in the path. There's another section of this course where we talk about using man-in-the-middle attacks for Ethernet, wherein we are spoofing the MAC address of the default gateway. We'll get into that at a later point, but keep this in mind. You can simply sniff the network, whether it's wired or wireless, and find hosts that are up and online and talking.